All right, let's take a look at doing some integration with inverse trig functions. So go ahead and pause and write these formulas down so we can use those. So the first question we need to look at is this one here. So integral of dx over root 1 minus x squared. So this should be equivalent to, that is going to be arc sine. So inverse sine of x, so plus c. This next one here, let's see, I'll line these up real quick. So this should be, if we look at this, this matches our pattern for arc tangent. And then this one down here is matching our pattern for inverse sine. We need to identify the u, so we have x squared, so u is x, and then a squared, so our a would be 2. So we put it into the format for arc sine. We have u over a, so x over 2. So we're doing arc sine of x over 2 plus c. So those are the basic ones, these first two. And then if we had a negative dx here, this would be arc cosine. Let's take a look at a couple more here. So let's take a look at this one here, this x plus 2 on top. What we need to do here is we need to split this up into two different integrals. So we have x over square root of 4 minus x squared plus, so it'd be 2 over the root, so I'm going to take the 2 out to the front. So now we have this dx over square root of 4 minus x squared. So this is the problem we just did. So we know that is the sine one. So we have 2 arc sine of x over 2. Because remember our a was 2 in this one. So we have that plus c. Now this one we would solve by doing some u substitution. So if we substitute, so our u would be the 4 minus x squared, and we did the u substitution, we would end up with the derivative of the inside would be 2 dx. So we would have 1/2 out there, and then we would integrate, well, it would end up being at the end, because we would have 1 over u to the 1/2 power. So we would end up with a, let's see, negative square root of x squared. Let's see. So roll through the u substitution, make sure you get that as an answer. Anytime we have two terms on the top and one thing on the bottom, we could split it up into two different integrals. This one we're going to have to recognize that we have a higher power on top, so we're going to have to roll through some long division. So once we roll through the long division, we're going to get a new polynomial, and then we can integrate that. So that's how you would handle those. And then one more thing we need to look at. Whenever we have a number in front of our u, so our u here technically would be the square root of 2x. So what we're going to want to do is we're going to want to rewrite this. Oops. We want to pull the 2 out. So we're doing square root. So if I factor out a 2, we're going to have 5/2 minus x squared. And now that we have a product inside of a root, we know we can do that separately. So we're going to have a square root of 2 come out. So we have 1 over square root of 2 coming out. And now we're going to have our a squared minus u squared. Now we can go ahead and we can identify this as arc sine. Our u is going to be square root of 5/2. And, or sorry, our u is x and our a is the square root of 5/2. So when we write this out, we have arc sine. So we have x divided by square root of 5/2. So if I flip it, we have root 2 over root 5. We could rationalize this to get a 5 on the bottom, and we would have square root of 10 on the top, or we can just leave it like this. So pulling this 2 out at the beginning underneath the square root allows us to have this. Now, you could skip through this step, and then at the end you could divide by the derivative of u, which the derivative of u would be square root of 2. So that's where that comes from. All right, so try some of these problems. You should be able to complete the rest of the assignment. And let me know if you have any questions.